Subscribe to AmpCode and ring the notification bell to get the latest content.
So now let's talk about the Spark SQL for querying the structured data. So when we are dealing with structured data, so this data could be present in a CSV file or the Parquet file, or it could be coming from any Hive table or any relational databases, because you already know that relational databases is used for storing the structured data, where the data is stored in the tabular format. So Spark SQL is the capability provided by the Apache Spark to able to write SQL queries on top of the data frame. So this is the advancement of the Spark data frames, and it is more suitable for the one comfortable to work with SQL, because sometimes working with data frames is also a very tedious task and it has a steeper learning curve, because you should be having understanding of all the functions that you need to perform data processing and data cleaning in terms of data if you are using only data frames. But SQL will simplify all the stuff. So if you know SQL, you can definitely write Spark SQL queries, because the syntax is pretty exact to SQL. So you can just create temporary view or temporary table on top of any data frame. First, you need to understand that you should be having a data frame and not the RDD to able to perform Spark SQL queries. So if you have existing RDD, you can convert it into a data frame, and then you can create a table, temporary table or a temporary view on top of the data frame. So that temporary table will be stored in your Spark application, and you cannot access that from the another Spark application. That is very important point, until and unless you save that data frame using the right method. So that you have to understand. So this temporary view or temporary table is only tied to your specific Spark session and the Spark application. So to able to do that, there is a pretty simple function which is create or replace temp view. So we are going to see that in a bit, but to give you a better understanding, Spark SQL works well with the data frame because of its structured data and it has the fixed schema. Okay, so without wasting any time, let's execute the Spark SQL query on top of the data frame. So in the last lecture, we already created a data frame on top of a CSV file, and we just saw the count of the data frame and also the schema of the data frame. But it's time to run some Spark SQL queries as well as some data frame operations on top of that file. So just head back to the Jupyter notebook and continue with our code. So as you can see in the previous lecture, we have already created a Spark session and also created a data frame on top of a CSV file. So our CSV file friends.csv had few columns like user ID, the name of that user, the age, as well as the friends that particular user has. So basically this is a pretty simple example, and it had like 500 records in them, and it has this kind of data. So basically we have already created a data frame on top of it. So now we just need to create a temporary view or temporary table on top of this data frame to able to run Spark SQL queries on top of this. So basically the first step is like you have to create the temporary view for it. So we just give like people dot create or replace temp view. So you can give table as well, it doesn't matter. So here I'll give the name as people only and just execute this. So basically now we have the temporary view which we can write SQL queries on top of it. So basically we can create another data frame using this. So let's create another data frame. So here we have like the data frame here, and you have to use the spark.sql here. So this SQL method is present in the Spark session itself, and we can just write simple queries in the text in the quotation here. So we can just write like select maybe all the records, so select star from, and here the view name is people, where the age is greater than maybe 30, right? This is a simple query. So once we execute this will create a new data frame called data using our Spark SQL query. So if we just execute this, okay, so as you can see, we have created a data frame on top of our Spark SQL query. So what we can do is to just verify it, we can just add another tab and then just show the data. So if we get to show the data, so this is how we are getting all the records having the age greater than 30. So it was a pretty simple SQL operation that you can do on top of the data frame. So you don't have to worry about learning any of the native functions which are present in PySpark module. So you don't have to worry about that. You can just simply create a temporary view or create a temporary table in your Spark session, and then you can just do all sorts of SQL operation on top of it. So this is just to get you started, and it is way more efficient as well. It's not like Spark SQL has some disadvantages over the native operations that we are going to see in the next topic. But you have to make sure that your queries are well optimized. You're using the right join on top of it, and also like you are using caching strategies very carefully, because you cannot cache every data frame because it may slow down your operation, because caching will require all the data should be pulled up into the in memory. So you have to make sure that you're using the right optimization techniques while developing your code. And also every expensive join operation, or you are unioning it, so you have to make sure that each operation is specifically designed for your end requirements. So as you can see, we were able to write some simple SQL queries on top of the data frame.
So that's it for today. I'll see you in the next lecture.